بسم الله الرحمن الرحيم. السلام عليكم ورحمة الله وبركاته. أهلا بكم أبنائي وبناتي طلاب الصف الثاني الثانوي. نبدأ مع بعض اليوم ريفيجن نمبر 3 في الكيمستري. في السيشنز المرة اللي فاتت عملنا ريفيجن على شابتر 1 واللوز اللي موجودة والويز تو سولف اني بروبلمز، والسيشن الثانية والثالثة اتكلمنا عن الشابتر 2 وبرضه اللي هو بقية شابتر 1. يبقى احنا دلوقتي السيشن نمبر 4 بالنسبة للريفيجن في الكيمستري ان شاء الله. نرحب بكم اولا ان شاء الله، نبقى موفقين باذن الله في هذا الترم، وربنا يوفق جميعا ابنائي وبناتي في جميع انحاء مصرنا الحبيبه. احنا نبتدي اول حاجه. انا اقول لك ايه اولا، احنا رجعنا ايه. احنا طبعا رجعنا ايه في الشابتر اللي فات. What was the views previous meeting. يبقى انا عندي هنا احنا ايه اللي رجعناه في المره اللي فاتت. تعمل ملخص على السريع كده. انا اول حاجه عملنا ريفيجن فيها الساينتست hypothesis for the concepts of the atom. يبقى انا عندي هنا شويه كونسبتس رجعنا عليها، مثلا زي الكوانتم نمبرز والابليكيشن على الكوانتم نمبرز، وخدنا الالكترونيك كونفيجريشنز و how can you use electronic configuration to obtain quantum number and vice versa, and graduations of these properties of atomic I'm sorry, the graduations of the properties of atoms. يبقى نيجي نلاحظ ان ايه الجراديويشنز ده بيعتمد على ايه؟ بيعتمد على الارينجمنت in these atoms in the periodic table. و how can you locate any atom inside the periodic table. electronic descriptions او electronic distributions and applications او سميها electronic configuration and its applications. وطبعا الفيمous application of that is انا عندي اهم حاجه نعرفها select the item type of locate the item in the periodic tables. I mean the atom inside periodic table. And relations between quantum numbers and the position of atoms inside periodic tables. Here, locate the item in periodic table relates quantum numbers to the location of the elements in the rules table and determine type. طيب، يبقى احنا هنا عايزين نتكلم عن ايه؟ نمبر 1 ال characteristics of the periodic table. What the characteristic of periodic table? periodic table له مجموعة properties او مجموعة characteristics of these او properties الاسهل ليك تقولها. تمام. دلوقتي انا عندي مجموعة من الحاجات نعملها ريفيجن على السريع كده like atomic radius وعندي الميتاليك ونون ميتاليك properties in the end of this property. ionization potential and electronic configuration, electron affinity, these are all properties here inside the periodic table. And I have redox properties, oxidation reduction reactions. ده بيعتبر حاجه لوحدها هنتكلم فيها برضو، هنعملها ريفيجن. تمام ان شاء الله. المهم احنا كل حاجه هنرجعها باذن رب العالمين بقدر الامكان. طبعا احنا بنعمل دلوقتي ريفيجن للكونسبتس these items like half what the meaning of atomic radius. Atomic radius half the distance. It is half the distance between the centers of two identical atoms in diatomic molecule. Absorbed energy to remove the least electrons bounds to the atoms. energy release. طبعا كل الكلام ده بيرتبط بمين؟ الحاجات اللي بطلعها دلوقتي بتظهر قدامك بترتبط بالمين كونسبتس او بسميها المين ايتمز اللي بتكلم عنها. دلوقتي انا بتكلم عن الكترون افينيتي. electron affinity of energy released when a single gas atoms gains electrons. Electronegativity, the ability of the atoms to attract chemical bonds to electrons towards it. And what the meaning of metallic and non-metallic properties? I mean solid except for mercury, which is liquids, and non-metals have different physical states. These are the some properties I discussed this before. Now we have the graduation of some properties of the periodic tables. Decrease in the direction decreases in the direction of the period as the atomic number increased. Again, decreases in this direction. This direction leads to from left to right, left to right, left to right. What the meaning of left to right? Left to right is this direction for the atomic radius, which is related with atomic number. In this way, atomic number increase and the atomic radius decrease because the effective of nuclear charge increase in this direction, where we have two conditions or we have two factors. These factors affects on the properties or atomic size. We have some things in this direction decreasing in the direction of periodic of the atoms. Maybe some students doesn't understand these concepts because may have many directions and I have many graduation. You must save one way only, and the other is what is a reversible direction. Now we have decreasing in this direction predictable as the atomic number increases for what? For the atomic size. مين بقى اللي بيحصل له هنا decreasing؟ أول حاجة عندي طبعا احنا قلنا مين؟ الatomic radius, and we have metallic properties in this direction decreases, and we have basic properties. We have three properties decreasing in this direction. Now we have increasing in this direction, of the same period was increasing the number of peaks. Okay, now we have number one is ionization potential increase by increasing atomic number and decreasing of atomic size. Now electron affinity increase in this direction, and we have electron electronegativity, so increase in this direction. Non-metal properties increase in this directions. Acidic properties increase in this direction. Now we have many things about this. Number one, we have a comparison of atomic radius and ionic radius. What's the difference between atom and ion? Firstly, I mean here negative ion and positive ion. How the ion appear? Ion appear when the atom lose one or more electrons from the outer energy levels of the atoms, but negative ion when it gains some of electrons from the outer energy level. So we have this definition is half distance between, the meaning if this is atomic radius, half distance between nuclei of two identical atoms in the diatomic molecules. These directions of periodic table, the atomic radius decreases across one period from left to right. Now we have due to an increase in a positive charge that attracts electrons towards the nucleus. Now the atoms or the atomic radius increases when moving from top to bottoms. Now in these groups, due to increasing the number of electrons, Fell's energy, we have many things affects on the atomic radius, but I want to know the ionic radius. Ionic radius may be more or be greater than or maybe smaller than. That is depends on which ion you discussed, positive ion or negative ion. You have positive is half distance between the nuclei of two identical ions in the case of a gas. Now, change in ion formations. Number three, cations. Positive ion, the ionic radius is smaller than the atomic radius because the atoms lose electrons, reducing the size of clouds. Anions, I mean negative anions, the ionic radius is larger than the atomic radius because the atoms gain electrons, increasing the size of the cloud. Now, I have many exercises. I must discuss this exercise with you to review good in this properties. In methyl iodide CH3I, the carbon hydrogen bond length 1.07 angstrom and the carbon iodine bond length 2.1 angstrom. Calculate bond length on hydrogen iodide if you know that the atomic radius of the carbon atom in 0.77 angstrom. Now, number discussions of here, you must know carbon related with 3 hydrogen. Now, and carbon related with iodine atom. Now you must know the bond between carbon and iodine equal to the radius of carbon and the radius of iodine. And the same things, carbon and hydrogen 0.7 angstrom. Now I draw these to understand 1 point. This is 1.07 angstrom. Now, and this distance equals to this number CH3 carbon hydrogen okay 1.07 angstrom. This is the bond length between carbon and hydrogen. Now, and the carbon iodine bond length, this is range equal to 2.1. Now RC, I mean radius of carbon plus radius of iodine equal to 2.1. Okay, now I don't have anything, just 2.1. now 0.77, which is 77, how can you obtain this number? This number 0.77 here, that's atomic radius of carbon atom is 0.77. So I have Ri equal to 2.1 minus 0.77, now equal to 1.33. So this radius of iodine equal to 1.33. Now iodine, this number, and carbon hydrogen, this number. Okay, now carbon and radius of hydrogen equal to 1.07 minus 0.77 equal to 0.3. Now I have radius of hydrogen. Radius of hydrogen plus radius of iodine equal to the bond length between H and I. So equal to 0.3 plus 1.33 equal to 1.63 angstrom. The bond length in a hydrogen iodide molecule is 1.63 angstrom. 63 angstrom. Okay, this is questions wants to graduate or rearrange these atoms according to atomic radius: calcium, aluminum, and magnesium 12. Firstly, you must make electronic configuration of calcium, aluminum, and magnesium. 20, so for S2, period is 4, group is 2A. 13, 3s2, 3b1, period 3 and group 3a. Mg12, 3s2, period 3 and group 2a. Now, the electronic configuration is the main regions for obtaining the number of groups and period in the periodic table of each atoms here. Now, sections of the periodic tables, arrangements we find here, period 3 and period 4. Period 3, magnesium and aluminum. Period 4, I have Ca. Now, in this direction, decreasing, in this direction, increasing. So, the true or the correct arrangement is aluminum, magnesium and calcium. Calcium is the greatest atom in these choices. This is ascending. If you know, if you want descending graduation, so calcium, magnesium and aluminum. This exercise, arrange the following in ascending order according to ionization potential. Sulfur 16, sulfur negative 2, 16, chlorine 17. The same idea. The same idea. You must using electronic configuration firstly. Okay? And after configuration, you must arrange it in the section of the periodic table. Now, first, electronic configuration of sulfur and chlorine and sulfur anion, negative 2. Okay, sulfur 16, the end of the sublevels is 3s2, 3b4, period 3, 6, 8 is a group. Now it's gained 2 electrons, 3s2, 3b6, 3, 6a. Now chlorine 17 is 3s2, 3b5, 3, 7a. Now we have these arrangements of S, 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 and Cl. Now, in these sections, okay, sulfur, chlorine, chlorine chlorine is greater than sulfur in the ionization potential. So S negative 1 is greater or lower than. Now we have S negative 2 is the greatest. Why? Because it's gained 2 electrons. Because it gains 2 electrons, now it don't needs to gain or lose any electrons. So S negative 2 is the highest ionization potential. Highest ionization potential. After that, chlorine. After this is sulfur. This is the descending arrangement. If you need ascending arrangement, sulfur, chlorine, sulfur, negative 2, it is a true arrangement according to this graduation for ionization potential. Now, I have the first ionization potentials. Noble gases is very high. First ionization potential of noble gases is very high. Now, when I told very high, I mean I make or I consumed as very high energy to make this things I mean. Ionization potential needs energy to lose this electron from the outer energy levels. Okay, by increasing the ionization potential, you can't decide what you can't decide now the atom's size or the atomic radius is small or very small. Now the smallest things here is very, very, very small. So now you can to know some things. The first ionization potential of noble gas is very high because noble gas such as helium, neon, and argon, krypton, and so on, characterized by the presence of complete outer electron shell. Now it is stable. stability of these noble gases make it they aren't need to lose or gain electrons. It is stable. They are stable elements. They are inert elements. They are noble gases. This means that it has very stable electronic distribution. There are several reasons why the first ionization potential of these elements is high, because it needs very high energy to break principal level, main principal level. Anyhow, electronic stability, noble gases possess a fully filled outer electron shells, making them very chemically stable, removing an electrons from this stable shell require high or large amounts of energy. The force of attraction of a nuclei to electrons. Now, the nucleus is very high in attraction force. This force of attraction force is in noble gases. The outer electrons are relatively close to nucleus and under strong influence of the positive charge of that nucleus. This makes it difficult to remove the electrons and requires high energy. Now, this energy very high because it's their great stability. Noble gases don't tend to lose or gain. I told this before. An electron easily. This means that's moving and main or principal levels energy. Now, the radius of sodium cation. The radius of sodium cations is smaller than Na. I told it again. The radius of Na positive one is smaller than Na. Even though they have the same electronic configuration. Now, I have sodium cation or sodium positive ion. It is electronic configuration like an ion in this electronic configuration. And neon Ne have the same electron configurations. 10 electrons, we have 10 electrons, there is a fundamental difference in ionic and atomic radius between them. Now, we have some factors for that. So, the radius of Na positive is smaller than Ne. The radius of Na positive smaller than Ne, even though they have the same electronic configuration. Because after losing one electron, okay, the number of protons inside the nucleus more than number of electrons in the outer energy levels. So the attraction force is more. But Ne, it is a neutral ion. It is a neutral atom. So have the same electronic configuration, I mean, but the main factors here, the attraction force for the ionic and atomic radius between them. Now, number of protons, sodium ion, Na positive has 11 protons in its nucleus. Neon atoms have 10 protons in its nucleus. Now, the force of attraction of the nucleus to electrons in the case of the sodium ion, Na positive. The positive charge of the nucleus 11 protons attracts the 10 electrons more strongly than neon. 10 protons, this adds to power, reduces the size of the cloud, resulting on a smaller radius. Now, I discussed this before for the factors which affects on the atomic radius or ionic radius. Now, I want to know the bond length in FeCl2. Bond length in FeCl2 is greater than bond length FeCl3. Now this problems is very easy to understand that. If you dissociate FeCl2, we have Fe positive 2 plus 2Cl negative 1. In this compound, we have Fe plus 3 positive 3 and 3Cl negative 1. The difference between two compounds depends on the cations types. We have Fe plus 2, here Fe plus 3. Now the ionic radius here differentiates for the ionic radius here. Now we have the force of attraction between the nucleus and the electrons in FeCl2. Iron Fe plus 2 contains 24 electrons, and we have 26 protons, so the number of protons greater than number of electrons. 26 protons, 2 missing electrons. Now FeCl2 irons Fe plus 3 contain 23 electrons, 26 protons, 3 missing protons. Now I'm sorry, electrons. So the gaps between here is 3 electrons and difference here is 2 electrons. So the attraction force in second is the most, okay, and Fe plus 3 is the most. So the ionic radius of Fe plus 3 less than Fe plus 2. So the bond FeCl2 is greater than FeCl3. It is logic. Now, in case of FeCl3, the positive charge on iron is greater and increasing the force of attractions between the nucleus and the surrounding electrons. This reduces the distance between iron and chlorine, thus reducing the bond length. So the Fe plus 2 ions in FeCl2 is larger than the Fe plus 3 ions in FeCl3 due to the losing of extra electrons in Fe plus 3. Smaller size of the Fe plus 3 ions leads to greater convergences of ions, reducing the bond length. Therefore, the bond length in FeCl2 is greater than the bond length in FeCl3 due to the difference in oxidation states and the force of attraction between the nucleus and electrons. Now, I have another exercise. Element X represents by its first 4 ionization potential are shown. First ionization potential, or first, is 737.7 kilojoule per mole. Second ionization potential, 1450.7 kilojoule per mole. Third ionization potential is 7732.7 kilojoule. Fourth ionization potential is 10,542.5 kilojoule per mole. What is the number of orbitals occupied by electrons with the ion if n equal to 3? Okay, now we have this number, and we have jumping from 1450.7 to 7732.7. What's the meaning of jumping? Jumping of raising of energy. This is raising of energy or increasing of energy, jumping from 1004 to 7007. Now this difference is very high. Now we can know from, or we can expect it to the ionization potential, or the number of electron loses is 2, not 3. Why 2? Because this high energy needed to break completely energy level. Now I have n equal to 3 with its sign f equal NO3. Okay, now this elements in group 2A. Okay, and you told before we have n equal to 3, so is 3 what? 3s2. 3s2. Okay, now we read this in slide. The elements in group 2A, because it needs a large energy to break the entire energy levels, because it was also found that third ionization potential is very large. This is a jumping from 1000 to 7732.7 kilojoule per mole. Now compare these values between the two sides, we find this comparison between them. We have the last second is 1450 kilojoule per mole. Now, hence, that group number was known as also used as a cycle number or a group number. So its electronic distributions ends with only 2 electrons only. Now is actual is 3s2. When it loses 2 electrons, so is 2b6. So the number of orbitals occupied by electron is how many? 1, 1, 2. We have 3 is 5 orbitals. Now it is the correct answer for this exercise. Arrange the next questions. Arrange the following compounds according to their acid strength. H2XO2, H4UiO4, HZO, H3WO3. Now write H in hydroxylic or hydroxyl. This is form XOH by 2, YOH by 4, ZOH, WOH by 3. You can to arrange it by using hydro OH. This is ZOH more than HOH by 2, more than WOH by 3, now YOH by 4. This is the correct arrangement for this strength of acid. Strength of acid. We have another. This exercise an elements whose ion X positive 3. X positive 3. At the fourth main levels contains electrons twice the number of orbitals in the sublevel F. So what is it? Now the atomic number of the elements, the 4 quantum numbers for the highest electrons energy in the atoms, items type or the atom type, the location of elements in the periodic table. Now please answer these questions and you can do explain for the answer. Now the number of orbitals in the sublevel F is 7 orbitals. So the number of electrons in the 4 major level is 14 electrons. Now we have this distributions according to main principal levels. We have K, L, M. K equal 2 electrons, L equal to 8 electrons, M have 18 electrons, N equal to 14 electrons. Now by using sublevels 1s2 and the first 2s2 to be 6 second, and the third 3s2, 3b6, 3d10, and the other is 4s2, 4b6, 4d6. Now it is the electronic configuration of positive 3, I mean ions. Now we wanted to convert into atoms. Now we have this KLM. Now we have the other is 15. Which 15? Because as the 1s2 and 2s2 2b6, and the other we have 3b, 3s2, 3b6, and 3d10, and the end is 4d7 because it's distribution. Now we have what? This is the other is now we have the other in the ends 1, 2, 3, 4, 5. Now we want what the electronic configuration in this values is 4d7. 4d7. Okay, we have many electrons, 1 2 3 4 5 6 7. Now we can to conclude from the previous steps have been identified both of atomic number is 45. Okay, we want to know the location, and these four quantum numbers are follows in order that 4 2 -1 and -half. So the item size main is this main transition elements. Now we finish all these exercises, and this is range 4, and the meeting is over, and we will see you later. God willings, my dear peoples, and thank you for good listening. Next session I will make the final revision of all curriculums. Thank you, my dear. Wassalamu alaikum wa rahmatullahi wa barakatuh.